Good evening and welcome to today's lecture on Redux reaction. Introduction. Redox reaction is defined as the occurrence of reduction and oxidation simultaneously. Oxidation can be defined as the addition of oxygen, the removal of hydrogen, the removal of electron, increase in oxidation number. For any reaction that an oxygen is added, an oxide is formed, such reaction is said to be oxidation. And if hydrogen is removed, such reaction is said to be oxidation. If an electron is also removed from a reaction to form a cation, such reaction is said to be oxidation. Now we'll move on to the other type of redox reaction, which is reduction. Reduction is the opposite of oxidation. It is the addition of hydrogen. While oxidation is the addition of oxygen, reduction is the addition of hydrogen. It is also the removal of oxygen, while in the other case, that is oxidation, it is the addition of oxygen. Reduction is also defined as the addition of an electron. If you add an electron to an atom, it becomes an anion. So reduction is the addition of an electron or decrease in oxidation number. For example, the reaction in which zinc changes from zinc ion to zinc atom. There is a change in oxidation number from +2 to 0. Hence, such reaction is said to be reduction because there is decrease in oxidation number, that is from +2 to 0. Let us look at how we assign oxidation number. Oxidation number of an element is its valency, or in an ionic compound is the charge on its ion in that compound. Let us look at the general rules of assigning oxidation numbers. The total sum of oxidation number in a covalent compound is 0. The total sum of the oxidation number in a covalent compound is 0. Elements in their uncombined state have oxidation number of 0. For example, chlorine in an uncombined state, that's Cl2, oxygen 0,2, hydrogen H2. In that state, they have an oxidation number of 0. Oxygen has an oxidation number of -2, except in peroxide, where its value is -1 generally, because the valency of oxygen is an electronegative element, and it needs 2 electrons to complete the octet configuration, so it has an oxidation state of -2 generally, except in peroxide, where such oxidation state is -1. And also, oxygen has an oxidation state of +2 when it's form an oxide of fluorine, because fluorine is highly electronegative. It's a halogen with 1 electron to complete its octet configuration. So because it is highly electronegative, its compound with fluorine tends to make the oxygen to be more positive, thereby giving oxygen a positive oxidation state. Hydrogen has an oxidation number of +1, except in metallic hydride. Generally, metals have they are highly electropositive. What do you expect? When a compound between metal and hydrogen are formed, when a bond between a compound of metal and hydrogen are formed to form a hydride, what do you expect? You expect that metal to be more electropositive, and hydrogen, which has the valency of +1, to change to -1. Metals of group 1A element, 2A element, 3A element has an oxidation number of +1, +2, and +3 respectively. Halogens have oxidation number of -1. Example of halogens are the chlorine, the bromine, the iodine, and the fluorine. These are all examples of halogens. The sum of the total oxidation charge of an ionic compound is not 0, but rather it is equal to the overall charge of the ion. For example, here in HSO4, it is -1. In carbonate 2 negative, it is -2. Let us look at this problem, assuming we are asked to determine a particular element in a compound. In this case, we are asked to find S in H2SO4, and O in hydrogen peroxide, and P in phosphoric acid. We can look at the solution. We follow our rules of assigning oxidation number. In S in sulfuric acid, hydrogen is +1. We put +1. We have 2 hydrogen atom in sulfuric acid. It will be +1 times 2 plus sulfur else, because it is the else we are looking for, which is sulfur, plus the oxidation number of oxygen is -2. We have 4 of it here. It will be -2 times 4, which is equal to 8. And the total sum of the oxidation number in sulfuric acid in this compound, it's a neutral compound, is equal to 0. So we sum it up, we make the S the unknown, and we'll do our little arithmetics, and we arrive at S is equals to +6, which gives the oxidation number of sulfur in sulfuric acid to be +6. Another one is when we solve for oxygen in hydrogen peroxide. In this case, we assume oxygen is X. So in hydrogen peroxide, hydrogen is 1. We have 2 of it, which is 2 into 1, plus oxygen, we have 2 here, which is equals to 2. And plus 2, we open the brackets. We open this bracket 2 plus 2x is equals to the total sum, which is equals to 0. Plus 2x, we'll shift the others, the plus 2, we'll shift it. That is taking care of our like terms. We'll shift it, and at the end of the day, we try to find our x. And -2 divided by 2, it will give us -1. That is what we have already said, that oxygen is -1 in peroxides and -2 in other compounds. So also, in this case, we find P in P2O07, 4 negative. That shows that the charge, the valency of this compound is not 0, but it is -4. We now solve it. We have our 2P minus, our oxygen is -2 times 7, which is 14, is equals to -4. We have 2P here. It will be 2P is equals to -14. 2P is equals to -4 plus -4 plus 14. It's supposed to be plus 14. It will be 2P is equals to -4 plus 14 is plus 10, which is P is equals to 10 divided by 2, which will give us 5. Therefore, giving us an oxidation state for P to be +5. Let us look at some common definitions we encounter in most redox reaction. We talk about oxidizing agent. What is an oxidizing agent? Oxidizing agent is defined as any substance that can bring about oxidation while on its own it is being reduced. It brings out oxidation somewhere, and in its own case, it's being reduced. For example, the halogens. Halogens can easily remove electron from metals. Removal of electron from our definition of reduction. It removes an electron, thereby it oxidizes the metal, while the addition of that electron to them reduces them, because addition of electron is a reduction. Reducing agent is defined as any substance that can cause reduction while on their own they are oxidized. E.g., alkali metals can easily transfer electron to electronegative elements which have high affinity for electrons, e.g. halogens, causing the electronegative element to be reduced. That is, the addition of electron into that electronegative element reduces the electronegative element, while the metal itself is being oxidized because there's removal of electron from it. Because in our definition of oxidation, we said it is the addition of oxygen or the removal of hydrogen or the removal of electron. So removal of electron means oxidizing it. Let us look at balancing redox reaction. Balancing of redox reaction is dependent on the media of the reaction. That is the media of the reaction. That is the reaction in acidic medium. Acidic is the medium in acid in nature, or is the medium a basic medium. Below are rules balancing redox reaction in an acidic medium. You divide the equation into two and write down the half equation showing how the species are reduced and oxidized respectively. You also balance all atoms on the left and the right hand side of the half equation except oxygen. In balancing the oxygen atom, water is added. Of course, you want to balance the oxygen atom, you add water. And also to balance the hydrogen atom, hydrogen ion or proton is used. Check and balance for charges by the addition of appropriate number of electrons. At the same time, check both sides of the equation and make sure that the electron lost is equal to the one gained. We are talking of balancing. So what do you expect? You balance all the atoms, you balance all the electrons. And at the end of the day, you sum the half equations and cancel out appropriately to get your final equation. Rules for balancing redox reaction in basic medium. The first one is rules in balancing in acidic medium, but this one is rules in balancing in basic medium. So what do you do here? One of the rule 1 to 4 is applicable to this one, that is balancing in basic medium. But however, the only difference is that in this place, what is applicable, instead of you take care of the oxygen atom in both half of the equation and balance with a hydroxyl ion instead of the proton. This is just a simple redox reaction for us to balance in a basic medium. These are the equations showing the reactions. In this case, you have our, let's take the manganese O4 negative, and manganese oxide in that end. So you take care of the oxygen here. You have you take care of the oxygen. You have 2 oxygen here. You now add 2 water in this end. You take care of the reactions, and at the end of the day, you multiply, and you bring out the final equation. And in this case, if you add the 2 equations, it gives you as shown in our on the screen. We sincerely thank you for keeping faith in us, and we are appealing to you to try to subscribe to our YouTube channel for more improved lecture. Thanks.